Some people will still roll in. Just make sure everyone can see my screen here. You should see the Flexim interactive PowerPoint presentation here. Thanks everyone again for taking the time to join us today. Today we're going to be going over the Flexim F601, which is the portable, but it's the same thing for the most part as the dedicated meters as well when it comes to navigating through the menus. So it should be very transferable skills. We're going to go through programming them, how to change the programming if you ever have to change it on pipes, or for the portables, obviously you're moving them around all the time. And then we're going to go through some troubleshooting things, so different errors that you can see and different ways to troubleshoot those errors. So this should look very familiar to everyone with the portable version. This is the portable Flexim. As you know, it has two channels, A and B. A is in the top left, B is in the top right, and to get started, all you would have to do is plug your transducers into the appropriate channel. So plug your transducers and start with channel A and turn the meter on. When you turn it on, it powers up and you'll see all the calibration information be loaded right onto the Flexim. There it is right there. It's telling you your serial number, and this is the main menu of the Flexim that should look very familiar to you folks. The four main menus, there's parameters, measurement, output options, and special functions. Special functions, you know, you can change your dates, times, settings. Output options is where you would change your output, your 4 to 20. You can change your units here. Basically, you can determine what you'd like the meter to display. But when you want to get started metering something, you would start with the parameters. You'd go into parameters and you would hit enter. Make sure that you're in channel A. If you want to measure on channel B, you hit these 8 or the 2. You'll notice they're lighter blue. So we'll start with A. And then it'll bring you to this menu for outer diameter. The big and most important thing here is that you are actually measuring your outer diameter, your actual outer diameter, and not the nominal diameter. So we have a pipe lookup chart. You folks can reach out if you don't have it. It should come with most meters, though, a printout of it, and it's a lookup chart to determine, you know, what the actual OD is depending on the pipe material. So for this example, we're going to start with 12.75. Wall thickness also in the lookup chart. For this is going to be 0.406. This is a 12-inch schedule 40 pipe. We can also use an ultrasonic thickness gauge to measure the wall thickness if you want it to be a little bit more accurate. Once you hit enter again, you get all your pipe materials, and again you would use those 8 and 2 buttons to scroll through all the materials. So choose your material, whether it's lined or not. Roughness, this is automatically calculated. This is essentially friction in a pipe. This number will be automatically generated based on the pipe material that you choose. A few other things you have to put in is the actual medium. If you hit the 8 and 2s, you can scroll through them all. Or if you have any special mediums that you guys are working with that aren't in the menu or that aren't in the Flexim, you can reach out to us and we can get a data file to put together for you to upload it. So it's a very versatile medium, or a very versatile flow meter in that regards. Medium temperature, just try to get this as close as possible. If the temperature fluctuates, make sure you're getting the average of them. Basically, this is going to affect the spacing of the transducers, though. And that's all the parameters that you need to put in. Once you finish putting in your parameters, go over to measurement, and you're ready to start taking measurements. So you make sure you have channel A marked because that's where my transducers are plugged in. If you have channel B, you use the 4 and the 6 to move left and right, and you hit the 2 to turn it on and off. So we're just going to do A. For those of you who don't know, channel Y and channel Z are math channels. So you can either do channel A plus channel B, you can do channel A minus channel B, you can do an average of the two to, you know, get a better flow profile. There's a lot of different things you can do with those channels Y and channel Z. This right here is the next screen. It says measure point number. This is a tag, so this doesn't affect the measurement at all. This just tells you that your data logger is on, and it's telling you that when you pull your data, it's going to be called, your data for channel A is going to be measuring point 1. You can change this to whatever you'd like. You would hit enter. And the sound path. So the sound path, we typically recommend folks starting with a 2 sound path. A 2 sound path is where the transducers are both on the same side of the pipe, and you mount the transducers, or in the ultrasonic beam bounces off the back end of the pipe and then hits your other transducer. So any even number sound paths, the transducers are going to be on the same side of the pipe, and then any odd number sound paths that you choose, the transducers will be in a direct mount on opposite sides of the pipe. Typically, if you start with a 2 sound path and you need more signal, we would go to a 1. But the more sound paths you have, it can also increase the accuracy, but it'll decrease your signal strength a little bit. So, like I said before, just start with 2, and you guys can take it from there. This is where it recommends the transducer spacing distance. We want folks to get as close to that number as possible. We know that with a crude measuring tape, 9.32 can be a little tricky to get for your spacing. So there is another menu after this that you can actually tell it what you put. So this, instead of 9.32, maybe just do 9.3 or 9.25, and it'll just, and then you can tell the meter that that's what your spacing did instead of the 9.32. On this menu, we also see that it's a reflect mount. So just in case you were wondering with your sound pass how you wanted to mount it, this will tell you right in this menu. The next menu is for your signal strength. Typically, we need about 3 bars of signal for you to get an accurate reading. That's 30%. This here we have more than enough. And you need to make sure you have a green light. The green light's indicating that there's proper communication between the transducers and you're ready to start measuring. This is the menu I was saying before, that you can manually type in the spacing for your transducers. So instead of doing 9.32, we can actually type 9.25, and it'll tell us right there, this is the recommended distance, and then this is the actual spacing that we did. All it's doing is changing the reflective angle of the transducers. And then once you enter one more time, you should be reading. You see here your gallons per minute. That's on the bottom. If you want to change the bottom display, you would hit this 3 button. You see it says DISP on the top. This is changing the bottom display. And then the 9 changes the top display. So for the top displays, you have your fluid temperature. This is the date and the time that the data logger will be full. It is in European, so this is actually February 10th. The data loggers can log 100,000 data points. The ring buffer is a special function that allows it to basically overwrite data while you're using it. So instead of it just logging and then stopping at 100,000 points, it'll just continually keep logging. This is just telling you it's transit time, and this is your spacing. Diagnostics for this. I was telling you guys about the signal strength before. If you have less than 3 bars, if you have a low signal strength, there's a few different reasons for this. One could be maybe an inappropriate transducer. If you're using using too small of a transducer on too large of a pipe, or maybe the pipe material is like ductile iron. A cement line ductile iron can be kind of tricky, so sometimes you need to use a larger transducer for that. Going to a larger transducer should increase that. You might have too many sound paths, so if you have maybe 4 sound paths, decrease it to 2. If you're doing a 2 sound path, maybe try the 1 sound path and do a direct mount. Poor pipe conditions or scaling on the pipe or corrosion, this could also cause signal strength being low. The best thing to do with that would be to try to move it to a different spot in the pipe where the pipe maybe isn't as rusted or scaled. or just the fluid could be dirty. It could be a poor application. That's for low signal strength. If you have a red light, that's a different story. This could be also undersized transducers. They're just getting no communication between each other. It could be a wiring issue. So maybe your J-box, or check your terminals, check your J-boxes if it's a dedicated meter. That's not too relevant for the portable meter. Again, make sure they're plugged in. And then maybe you could be using the wrong mounting. So if you're doing a 2-sound path and you have it in a direct mount, so on either side of the pipe, it's not going to read that because it's bouncing the ultrasonic beam off the back wall and trying to communicate with another transducer on the same side of the pipe, but it's not there. So just verify your sound path as well. The final error that you guys can get is a flashing green and red. You'll see that here. This could be a number of things. It could be air passing through the pipe. It could be maybe turbulence from an opening and closing valve if the meter is very close to a valve. This could just be poor flow conditions. If you're coming off of a 90 and it's struggling to pick up, good flow off of that. Try to find somewhere with a little bit more straight run. Could be too many solids in the pipes. It can read up to 5% solids, but too many solids will affect that signal. And then this could also just be very, very, very bad buildup on your pipe. Again, try to find maybe somewhere else in the line, or if you really can't do that and you want to put a flow meter there, cutting into the pipe and putting in a clean spool piece, a stainless steel spool piece, you'd get very good signal and that would stop. Those are the possible errors when it comes to the signal strength, or signal strength and the channels being red or green. Other diagnostics that you want to look for when you're in this gallons per minute menu, if you go hit the 3 button, you will see the sound velocity. This should also be in the lookup chart with the pipe lookup chart. Again, please let us know if you guys don't have this, and we can definitely send it over to you. But every medium has our ultrasonic beams move through every medium at a different speed at different temperatures. So, for example, 1485. This is a little bit warmer than room temperature water. You would just have to look up at the temperature that you're at in that sound speed lookup chart. You're allowed to be plus or minus 50 for your sound speed. So if I was, 1435, that would be at the low end of acceptable, and same thing with the high end. But if you're more than 50, this isn't more. I should have changed this to more. But if you're more than 50 meters per second off from what you should be, this is usually a wall thickness issue. So maybe you chose the wrong schedule of the pipe. You thought it was schedule 40 and it's really schedule 80. It could also be strong buildup in the pipe. So maybe there's so much scaling in the pipe that it's actually increased a 1/4 inch, 1/2 inch. And what we would recommend there is you just slowly start to increase that wall thickness until you can tie down the sound speed. It could also be a transducer spacing alignment thing. Make sure that your transducers are level with each other and the spacing is appropriate. Like I said, it could be scaling, or it could be the wrong temperature. Maybe the medium is actually at a higher temperature than you thought, so you're getting the right sound speed. If you're off by 120 or more, if you're off by a lot, this could be a wrong size pipe. Make sure you go back and measure the pipe again. Make sure you're getting the proper OD. You're using the actual OD and not the nominal OD. Make sure you're choosing the correct media. Those are some definitely usually the key reasons why you would get a very off sound speed like that. So that's if you're off like 120 or so, and then if you're way off, like not even close. I'm looking for 1480 and I'm at 2000. This is definitely you have the wrong pipe parameters. Maybe you just go back through the parameters, make sure you're 100% sure about everything. It could also be foaming in the pipe, or basically this could also be the sound or the sound speed just not communicating with the other. If you have this high sound speed and you have a red light, that's the transducers not communicating with each other, and it's just the ultrasonic beam bouncing back and forth a lot inside of the pipe. So yeah, definitely go back and check, make sure you have everything plugged into the parameters properly if you have that off of a sound speed. And for the most part, that is how you program a meter and how you measure with it and troubleshoot it. I'll now open it up to any questions.
Zach?
Hi.
Can you hear me?
Yes.
Okay, you mentioned something about a stainless steel spool piece.
Yes.
Is that something we can order from you?
Definitely, we can definitely get you guys a stainless steel spool piece if you're having issues with a a rusty or built up pipe.
Are the transducers permanently mounted in them? Is that how that works?
We could do a permanent mounting, but I mean it's still the same setup. So we would just be doing the spool piece, so you get a clean. We read really well on stainless steel.
Okay.
So we would just be getting a clean spool piece, and then we can with the solid coupling pads, it is a permanent installation, so you shouldn't have to touch it anyway.
Okay.
So yeah. I think a lot of people are muted. If you have any questions, you can type them into the chat as well.
Hello, I have a question.
Yeah.
So we use the portable flow meter a lot at wastewater and water treatment plants.
Okay.
And a lot of times we're not sure whether the pipes are lined or not. So I wanted to just ask if there's any kind of like good assumption to be made most of the time. I think typically we just assume it's not lined, but if there's any way to be more accurate about that assumption.
It's a good assumption saying that it's not lined. If you're working in wastewater, I would say if it's ductile iron, most of the time it's going to have a double cement lining.
Okay.
But for the most part, carbon steel isn't lined. Like stainless steel isn't going to be lined. Ductile iron, 99% of the time, is going to have a double line cement.
Zach, can I jump in for a second?
Please.
Alex, hey, how are you?
Good, how are you?
Glad to see you on here. Just to jump in on that, in my experience in the past 8+ years, I'd say 99% of wastewater is ductile iron, and you can tell by like the orange peel on the outside of the pipe. The older stuff tends to be the class 52. The newer stuff, they seem to have switched up to class 53. And they're always seeming, unless they tell you otherwise, just assume it's double cement lined. And when you put that in there and you check that sound speed parameter, that will tell you if you have the correct parameter or not. So if you put in the ductile iron and then you find out that the sound speed's off and you put in the double cement line, try the single cement line, and that might bring you in line. Also with wastewater, since you have solids and stuff scraping the pipe, they tend to wear out. So sometimes even if it started as a double cement line, it might not be one anymore. So you might want to play with that wall thickness and kind of dial in your sound speed that way.
Gotcha.
That's a good question, because a lot of times we don't know.
Yeah, thank you so much.
Also, one thing to jump in on that Zach mentioned about the sound speed diagnostic while we brought it up, that sound speed of 2000 is also the sound of empty pipe. So sometimes you might think a pipe is full, but it's not. We ran into that at a wastewater facility in New Haven, Connecticut here, where we were trying to measure, and when we set up the system, there's nothing flowing. But the minute they turned on their pump, it siphoned the pipe empty. So we went from fantastic diagnostics to that 2000 sound speed diagnostic, which led us to look into it. And that's when the engineers got involved and realized that they have a siphoning effect and that you can't measure in the spot that they originally wanted to. So the sound speed's a great diagnostic for a few things. A, making sure you have the correct parameters and the correct pipe. B, making sure you're measuring the correct media. I've done stuff on chilled water before where everybody swore up and down to me that it was just straight water, but I was getting a diagnostic that was in the 1600s, which is indicative of glycol. Then someone walked by and was like, oh no, we use 30% glycol. And then the past 2 hours of troubleshooting were useless because I was right all along. It was just an error on communicating to me what media it is. So it's a very powerful use of a diagnostic. Also, it can help you diagnose air in the pipe. If you see that the sound speed kind of jumps from where it's supposed to be to 2000 and back and forth like it's ramping. If you go and look at your signal strength screen, you'll actually see that ramping up and down like a bass on a amplifier. And what that is the slugs of air. So someone has to go and get the pipe rid of that air. We say that a lot on brand new chilled water installations where they haven't removed the air out yet. And a way to diagnose that is if they could stop the flow of the water and let the pipe settle, and we have good full pipe, good sound speed. And then when the pumps are turned back on and you see that ramping, that just shows you that there's actually air in the pipe. So it's a good tool in that regards for diagnosing different problems.
Does anyone else have any questions? Again, you can ask them or type them into the chat box. All right, it doesn't look like it. So thanks again, everyone, for joining us today. This was a great learning experience for us. We're planning on putting on more webinars to continue to, engage with you folks. So if you guys have anything that you might want to see us do a webinar on with any of our products, please let us know. We love your input. And yeah, everyone stay safe and have a great day.
Thanks, everybody.
Thank you.
Thank you.
Thank you.